Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about insight creation in kickstarting our organization to become data-centric. Welcome, Sarah. This is our fifth session that we're talking about data-centric organizations. And today, insight creation, we're going to talk about tools.
We're going to talk about data analytic tools. And also, we're going to understand a little bit more what machine learning really is and what it really isn't. So we'll try to debunk some myths around machine learning.
So before we start debunking, let's go back a little bit. Last time we talked about the data pipeline. Yes. We talked about ingest, analyze, prepare, thank you. See, I'm still learning. I'm still an IT guy. Ingest, prepare, analyze, and act. Yeah. But we didn't tell you how to do any of that stuff. Today, we get to actually get our hands dirty a little bit and learn about the tools that we plug into that pipeline. So, all right, teach me. I'm teachable today.
Okay, so let's start thinking about, what we are going to do with our data. And, what I mean is you always have to think about the end in mind. And in the last video, we talked about, a simple question about how many widgets, we will need to manufacture. And we kind of broke that down into a few different parts, customer demand, the current supply, and then also yield loss. So we broke that into a simple formula, but then we started asking kind of where does this data come from? How do we put this together so that we can estimate the amount of widgets we have? And we looked at the complexity about that. So, part of the whole concept of, the data pipeline is how do we need to take that data from the raw form and convert that into insights. So a lot of the time, what you hear about 80% or 90% of a data scientist's work is actually going through the prepare stage. So they're looking at, where's this data coming from? How do I store it? How do I need to get it to a point where I can combine that data? How do I need to combine it? And, how do I need to transform it so that I can put it into an algorithm and figure out what to do with that information so that I can be able to get some kind of, be able to estimate or, glean the pattern recognitions that are on that I can say, hey, this keeps on happening, and I can make some kind of predictions. There's a lot of work that has to go on that. So you have to start thinking about, okay, what tools am I going to be using in order for me to be able to get those insights? And when you look, we think about, hey, I'm going to apply AI or machine learning. It's not really AI as one algorithm or machine learning as one algorithm. It is really a bunch of tools in a toolbox that data scientists can pull out and say, okay, I think this is the best tool to be able to, deal with this. Or I'm going to try a whole bunch of different tools and figuring out if this is going to solve my problem. Does it actually recognize patterns that I need to, be able to understand and turn that into some kind of insights?
So, my neophyte way of thinking of AI was that I just create a neural network and I train it and it just solves my problems for me. And I know I'm not alone in thinking that. So It sounds like it's a lot more complex than what, me as a software engineer thought. I thought, hey, that's just an algorithm who, no big deal, but it sounds like it's a lot more than that.
It's a lot more than that. An algorithm is not going to tell you how many widgets are going to be able to manufacture. One algorithm is not going to be able to even be able to break down and say, hey, I have this many requests from customers coming in. I already have this supply and I have this yield. that actually is going to, what I'm going to be showing to you today is that it's really a blend of workloads that are targeted to be able to support those questions, and being able to figure out where are the different sources that can help us give better clarity on what could be happening. So, you know, you have to look at it, data analytics. You know, there's so many different ways you can break this up, and it's really hard to, because they're very much overlapping. And if you can see the petal that I have, this kind of this is something that a colleague and I created here at Intel, just to give an idea of the complexity of the tools in the data scientist toolbox. And just to let you know, not everyone's experts in everything. Like there's a few of these I couldn't even explain because I don't have a background in. So this also kind of reiterates that, you know, data science is a team sport. People have different specialties. Like my background is statistics. So designs, experiments, reliability, and machine learning and simulations, I have backgrounds in. I can talk about that. And maybe a little bit optimization. Some of these other areas I haven't had exposure to, and I have worked with other colleagues who are experts in that. So, you know.
So it's very much like in an IT organization, right? You've got network engineers. You don't take your network engineer and drop them on a storage architecture or a compute architecture, or you don't take a systems engineer and tell them to program a web interface. There's different disciplines, different tools. I get it. That makes sense to me.
So you really want to be able to look, you know, you need to have somebody who's can help you, you know, think about what questions you want to have. This is really going back to the business value, and being able to break this down and figuring out what are the, you know, the backgrounds that you need to be able to solve this. So this is one of the big complexities around analytics is, you know, they say talent. Well, you know, if you go hire a deep learning engineer that, you know, specializes around image recognition, they're not going to necessarily be able to solve your yield analysis. They might be able to detect, you know, put a system together to be able to detect defects, but no, you know, which could be of value to know if you have a defect or not. But that doesn't solve the problem of your yield loss. It answers one question in the multitude of questions you could be asking in that manufacturing line.
In your petal diagram, you show all these tools in different flavors and things. How do I know what to use? I mean, you got to help me out here.
Yeah. So, you know, don't worry about so much that, oh, which tool. This is why you hire a data scientist. They're going to work with domain experts to understand, you know, what information is out there, how reliable the data might be, or how to interpret it's probably more like interpret the data so that you can figure out how reliable the data is. So, you know, let's go back to our problem with how many widgets to manufacture. And let me break it down into kind of some type of analytics that you would use. And I'm not saying that this is the way. It really comes down to how you ask the question, what type of data you're having, and what you're trying to do with that data. So I'm not saying that this is the methods to be used. You might find out you need to use totally different methods because of the type of data and the dynamics of what you're trying to
But this would give me a good starting point, right? I could say,
it's a great starting point.
All right, let's start there and see what happens. I got it. All right.
Okay. So, you know, you start with the questions, and then you're going to go through what I call the analytic maturity development, which is really basically, you're going to look at, okay, what kind of patterns are there? So you're going to go through some descriptive. understand what has happened in the past. You're focusing on the past just to understand kind of what patterns. So you're going to try to figure out, okay, like from a customer request, you might want to start looking at some time series data just to be able to see kind of when things go up and when things, the requests for widgets go down. How stable is that over time? How well are you going to be able to forecast that in the future? You might also be doing some machine learning around here to kind of look at maybe different segments and understand, to break out some of these time series. Maybe you have one segment of customers who, request things end of the month versus others that are beginning of the month. That might help provide some ideas of segmentation and so forth. You might also want to do some text analysis. I have text analysis on a couple of these where you're going to be going and get different information. You might be, if it's a widget that people might Twitter about, you might want to go and figure out, what people are talking about that. Did all of a sudden the number of sharing or likes occur much more, that somebody who's an influencer, is influencing for people to, buy these widgets. So these could be some data sources. These are some techniques that you might be wanting to include in this to be able to estimate customer requests. Likewise, you could do something very similar with current, the current supply. Look at how stable the current supply is. How well do you understand the system dynamics of being able to go out? So you might have customer requests, but you might also have a supply going on, and you need to understand kind of how does your current supply get absorbed into the market on that. So there might be some system dynamics that you might need to go and be able to understand. This is something, again, a machine would never be able to do. This is a human has to go in and figure out and understand and kind of program or incorporate this knowledge into the way that you do your analytics. And that can only be done by a human, not necessarily from a machine or an algorithm. Likewise, there might be some other types of machine learning patterns that you want to get out that give you some ideas of some insights. So you might do some unsupervised learning around here. Unsupervised learning is really looking at, are there different categories or segments out there that you're not aware of that behave totally different from each other? And then you can start looking at those and try to figure out, okay, what is happening in this, and how can you're basically breaking up into these categories and looking at the behaviors around that and trying to figure out, how can I exploit this so that I understand, or I can track better, you get the better resolution of what might be happening with these groups.
Okay, so this is starting to make a lot more sense to me now. Depending on where my data is coming from, and depending on what I'm looking at in that data, I'm going to use a different tool. Yes. Understanding what the benefits are of each tool is the key. For example, I'm not going to use time series analysis to find to find yield loss by looking at images. It just doesn't make sense.
Right.
I'm going to use more of a neural network. I'm going to use machine learning to do something like that, real pattern recognition that way.
Right.
So this is starting to make sense. There's a big toolbox out there. So let's talk about yield loss, because this is where I think this is the hard part, right? For a lot of people.
This is the hard part. And this is depending how complex your manufacturing is. And, I've worked in, automotive, food, and semiconductors. And, some of them are, less complex than others. Semiconductor probably being the most complex. All kind of manufacturing is complex, some more complex than others. And it's really understanding where the variation is coming from. The more variation in your manufacturing line, the more waste that can be occurring. So a lot of the machine learning is really trying to, just like I said in the current supply, you're looking at segmentations. Are there, days, certain behaviors of yield that occur? What are they? So you might have, again, clusters of different types of yields, and then being able to figure out, how do you quantify that and how do you predict that? And you could be using unsupervised, that's the being able to cluster, or be able to learn how to predict yield issues based on behaviors or features that are occurring within the manufacturing line. Okay, so one of the things that we do a lot within manufacturing is designs of experiments. So we understand what, what are the factors that can optimize, the overall yield or minimize the yield loss. So you might go through and just look at, here's machine A and machine B, and that if they're not optimized to perform together in the right way, you might go in and just say, hey, if I do this design an experiment and play around with a whole bunch of levers or knobs on there in a systematic way, and then look at what happens to the yield. You're doing a design of experiments that basically shows you what exactly is the right knob combinations to be able to set. And then you can put together, some rules or process control around that so that these knobs don't start doing drifts. Okay. So that's the power of designs of experiments, is really to start looking at, what is a really great way to be able to estimate causation on here. Now, sometimes you can't necessarily do that. There's other techniques that you can do to try to fit, other kind of designs of experiments that can do, we can't change all the knobs. There's other ways around to be able to do that. Talk to a data scientist. Another opportunity or another analysis is reliability, or it can also be called survivability, depending on which way you're looking at it. For example, in manufacturing, you have tools that are constantly being used and they might need predictive maintenance. So over time, they start degrading their performance. So there's a reliability in a couple of ways. One, to be able to predict when a machine needs to be maintained, so that the yield doesn't contribute to yield loss. Text analysis is another thing that, a lot of manufacturing is starting to get into. Not so much that, hey, the widget's going to start, doing Twitter or anything, but, if you have, and this goes along with predictive maintenance. If your technicians are writing up what they're seeing, how they resolve the problem, and you have multiple technicians, not only over different shifts, but maybe even over time, you can start having a collective knowledge base from this text analytics, where you can go back and figure out what was the best way to approach different issues, or how to correct issues in predictive maintenance. Some of the things that you could also do is deep learning around image recognition. Being able, instead of having a human, bunch of
right?
quality.
Yeah.
What was that? Humans.
A human, yeah. It reminds me of the I Love Lucy episode, right?
Right.
We all know that episode where she's picking chocolate off of the conveyor belt. We're replacing her with some deep learning, right, where they can detect flaws, errors during
flaws, right? Being able to detect and maybe even being able to categorize the type of defects that you have. You can take that and tie it back to maybe some text analysis, from some experts and so forth that, maybe, or even with your, machine learning that help, identify where the problems might be coming. So if you categorize a defect and you know that this defect is coming, you've seen this type of defect when, machine A has been having a problem, along with a couple other, phenomena that are happening within your manufacturing line. This is a great way to be able to go back and be able to, troubleshoot this.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.